In this video, I'm going to show you how to solve rational inequalities like this one. But first, I'm going to show you how to solve a simple inequality like this one, because baby steps. Well, the key is to start by solving the related equation. So the first step is going to be to solve x squared minus x minus 12 equals 0. This will give us something called critical values. So I can easily solve this by factoring. So that's going to be x times x, 12. 12 is interesting because 12 can factor as either 3 times 4 or 2 times 6 or 1 times 12. I need the middle term to be -1, so 3 times 4 is my best bet. Because if I have a positive 3 and a -4, that's going to make -1. Also, positive 3 times -4 is -12, so that's going to work out great. So we factored it. So now using the zero product property, this gives us x equals -3 and x equals 4. Of course, these are not the solutions to the problem. This is an inequality. These are just some critical values that we need to keep track of. And so what's going to happen is I'm going to wind up graphing my solution set on a number line. And these critical values will tell me it will split up my number line into zones. So I have a critical value here at -3. So I'm just going to put -3 just like this. And I have another critical value over here at 4. Now, we want values that are not equal to 0. We want the function to be greater than or equal to 0. However, because it says greater than or equal to, the points that make the function equal 0, those points are to be included. So the bottom line is, because of the or equal to part of this, these are going to be closed circles on my number line. Okay, these will be closed circles. If this had just been greater than, I would have left these open circles. That's the bottom line. Okay. Now we need to do some test values. I have 3 different zones here. I need to check out what is the value of the function in each one of these zones. So over here, it might be interesting to check what's happening at, for example, -4 would be in this zone over here. In here, between -3 and 4, what would be the easiest value to test? 0. All right, anytime you can use 0, go for it, because that makes the calculations easier. And a number that's in this interval to the right would be 5. So let's check out the value of the function at 5. All right, let's check out each one of these values. So if I substitute -4 in here, all right, I think I will do the calculations off to the side. All right, so I think I'll do the calculations down here somewhere. So if I substitute in -4, that would be -4 squared minus -4 minus 12. So that would be 16 minus -4 is really +4 minus 12. So that would be 20, all right, adding these together, minus 12. So that's going to be 8. Okay, so this turns out to be 8. But look, all that matters, all we care about is this greater than 0 or not? So this is greater than 0. In fact, okay, maybe I'll just organize it this way. So I just checked f at -4. Okay, and I got 8. The ink was too big. So I got 8. The question is 8 greater than 0? And the answer is yes. That means that -4 is a solution to this inequality because it makes the function greater than 0, and that's part of what we want. I'm saying greater than and not greater than or equal to. We already covered the equal to part. That's what the dots are. So because we have a yes, that means this is a solution. But the cool thing is that means every point in this interval is a solution. So I'm going to show that these are solutions by drawing an arrow right here. All right, next I'm going to check 0. What is the value of the function at 0? Well, if I plug in 0 for the x values, then that'll be 0 squared minus 0 minus 12. So obviously that's just going to be -12. So I've got -12. Is that greater than 0? Well, that's a big fat no. All negative numbers are less than 0. So that means 0 is not a solution, which means none of the values in between -3 and 4 are solutions. So now let's check the value of the function at 5. So if I plug 5 in, then that's going to give me 5 squared minus 5 minus 12. All right, and we're asking ourselves, all right, is that greater than or equal to 0? Well, this is going to be 25 minus 5 minus 12. And so this will be 20 minus 12. So again, that's going to be 8. So the question is 8 greater than or equal to 0? And the answer is yes. It is greater than 0. So that means 5 is a solution, which means that everything in this interval is a solution. And I will show that by putting an arrow right here. So for our final answer, we need to go ahead and express our answer in interval notation. So this graph gives me an easy guide to follow. So this first portion is from -infinity to -3. See that it's a closed circle? I'm going to go ahead and put a bracket on that. And then union. And then we have this interval over here that goes from 4 to infinity. Again, it is a closed circle, so I put the bracket. So this is really the solution to the inequality right here. Okay? Take a look at problem number 20. Okay, now this is going to be a little bit more complicated because it's a rational function. The previous problem was just a polynomial inequality. This has a fraction in it, all right, where we have x's in the denominator. The first step, though, is still going to be the same. The first step is to solve the related equation x minus 5 over x plus 3 equals 0. All right, let's solve this related equation. Well, the only way for a fraction to equal 0 is if the numerator equals 0. That's the only possible way. The denominator can't be 0 because that would be undefined. So setting this entire thing equal to 0 really means that we're setting the numerator equal to 0. Okay, so that's going to be pretty simple because we immediately get x equals 5. So this is a critical value. Now, there's another critical value that we didn't have to worry about for a polynomial. But in addition to solving the related equation, we will get other critical values based on what is undefined. So we know that the denominator cannot equal 0. So that means that x plus 3 cannot equal 0. Subtracting 3 from both sides, that tells us that x cannot equal negative 3. So we have two critical values. So we're going to set up that number line like we did before. But we will have both of these critical values. So we have negative 3 and 5. So I've got the negative 3 over here, and I'll put the 5 over there. Now, the illegal values. If x cannot equal something, that is automatically going to be an open circle. All right, it cannot be included, cannot equal negative 3. The other value, in this case the 5, it depends on whether or not there's an or equal to here. If it's or equal to with a little line under it, then it will be a closed circle. Since we have strictly less than and not equal to, then this also will be an open circle. All right, so sometimes this will be open, sometimes this will be closed, but the not equal to numbers will always be open circles. So the rest of this is just like we were doing before. Let's pick our test values. So in the first interval, a good value to pick would be the value of negative 4. Let's check f at negative 4. In this interval, again, 0 would be good. All right, let's see what happens at 0. And in this interval, it would be good to pick 6 and see what's going on. So I'm going to do those calculations underneath this line right here. Okay, so at negative 4, that means we would have negative 4. Okay, I'm looking at the original equation. So I'd have negative 4 minus 5 over negative 4 plus 3. Okay, and the question is that less than 0? Well, this is going to give me negative 9 over negative 1, which is just positive 9. Okay, so we're getting positive 9. But the question is 9 less than 0? All right, there's a big old question mark on that. Is 9 less than 0? No. Obviously, 9 is greater than 0, so I'm just going to say no. That means negative 4 is not a solution to the inequality, so there will be no solutions here, so we'll leave that blank. Next, let's look at 0. So we would have 0 minus 5 over 0 plus 3. That would give us, so the zeros are nothing, so then we will just have negative 5/3. The question is negative 5/3 less than 0? I'm going to put it up here. Is negative 5/3, is that less than 0? Yes, yes it is. All negative numbers are less than 0. That means 0 is a solution to the inequality, which means that all of the values in this interval are solutions. And finally, let's check the value of the function at 6. If we put 6 in, then that'll be 6 minus 5 over 6 plus 3. So that's going to be 1 over 9. All right, so the question though is it less than 0? All right, is 1 over 9 less than 0? No. Okay, that is a positive number. It is not less than 0. So we will have no solutions in this interval. So the solutions are all between negative 3 and 5. So in interval notation, we would say -3, comma 5. Now this looks just like an ordered pair, like a point, but the context tells us that these are all of the values from -3 to 5. I'm using parentheses for the same reason that I had open circles, to show that -3 and 5 themselves are not solutions. Okay, moving on to number 21. All right, we're going to use the same basic strategy. The first step is to solve the related equation. So if we were to pretend that this was an equal sign and solve it, that's the first step. But the only way for a fraction to equal 0 is if the numerator equals 0. So really, we're just doing x plus 1 is equal to 0. So obviously, that's going to give me x is equal to -1. That is a critical value. I'm going to have other critical values based on what x cannot equal. So let's look at these two factors right here. 12x plus 6 cannot equal 0, because that would cause a 0 denominator. So adding 6 to both sides, that means that 12x, did I say adding? Subtracting 6 from both sides, that means 12x cannot equal -6. Dividing by 12, that means that x cannot equal -1/2. So there's another critical value. All right, so I've got a critical value here. I don't feel like I should circle it. Maybe I'll highlight it later. Because if I circle it, you might think that those are answers. So I can get another critical value because 3x plus 4 also cannot equal 0. So that means that 3x cannot equal -4. I subtracted 4 from both sides. That means that x cannot equal -4/3. Okay. So these are my critical values right here. Time to highlight them. Here's one that x can equal. These two are the two that x cannot equal. I am distinguishing between those two types because when we make our number line right now, all right, we're going to have space for this. Okay, when we make our number line right now, whether or not they are open circles or closed circles will partially depend on whether it can equal the number or whether it can't. So, man, I feel like I need all of the space. So I'm actually going to put my number line down here this time. All right, because we have 3 critical values and I really want to spread them out. Okay, -4/3, that's like -1.3, right? Putting that in my calculator real quick. 4 divided by 3. Yeah, so -4/3, that's going to be -1.3, approximately. All right, maybe I should just also say that this is -4/3. And then close by, we have -1, which is not very far apart at all. I'm just going to put it over here to leave space for my work. But so there's -1. And then later on, we have -1/2, which would be like right here. Okay, good to know. All right, I moved it down here. I think I'm just going to swap these around for some reason. Okay, so this is negative 4 over 3, which is approximately negative 1.3. So it's time to pick our test points, our test values. We need something in this first interval, so that's going to be anything to the left of negative 1.3. So for example, I could do negative 2 would be fine. This is going to be the tricky one because between negative 1 and negative 1.3, there's not very much space in between here. So there are really only a couple of things that I would use, either negative 1.1 or negative 1.2. Okay, anything like that. So I think I'll just use negative 1.1. All right, so I'm going to check negative 1.1 as a test value. All right, now similarly, in between negative 1/2 and negative 1, and this is the same as negative 0.5, I might, for example, use negative 0.75. Okay, would be in between negative 0.5 and negative 1 would be negative 0.75. All right, it's a little hard to see that negative sign. Let me just make that a little bit more clear. So negative 0.75. All right, so this bothers me a little bit because of the decimals, but I don't see any way around it. And finally, in this interval on the right-hand side, time for good old 0. All right, at least that one's going to be nice and easy. Now, how much space do I have underneath here? All right, it's time to start doing these calculations. First of all, let's put these points up here. Everything that x cannot equal, these will automatically be open circles. So the negative 1/2, that's got to be an open circle. The negative 4 over 3, that's going to be an open circle. Okay, the other one, the one that x can equal, will either be an open circle or a closed circle, depending on this. Because we want the function to be greater than or equal to 0, well, negative 1 makes the function equal to 0. So that's okay. So we want negative 1 to be included, so we will make that one a closed circle. Now we just start needing, we need to start doing these test values all over the place. So I'm just going to scroll down a little bit so we have space. But you know, I guess I can't because I need to see what's going on. Do I have space over here? Man, I just feel like I need more space. Okay, if I plug in negative 2, in fact, this is what I'm going to do. I'm going to do these calculations and just erase them. Okay, so if I plug in negative 2 for all the x's, so that's going to give me negative 2 plus 1, and I'm going to have 12 times negative 2, okay, plus 6 times, all right, 3 times negative 2, plus 4. All right, now keep in mind, all the while we do this, the question is it greater than 0? All right, we've already covered the or equal to part, so is it greater than 0? That's all we care about. Is it positive or negative? All right, so if there's a way for me to tell without doing every last calculation, then that's great. So in the numerator, I'm going to have negative 1. Okay. In the denominator, I'm going to have, so this is negative 24. Okay, so this is negative 24 plus 6. Okay, so that is going to be negative 18. Okay, and this is going to make negative 6 plus 4, so that is going to be negative 2. So I've got negative 2. All right, so this is going to be negative 1 over positive 36. All right, negative 2 times negative 18 is positive 36. So this is a negative number. Okay, is that greater than 0? All right, so is this greater than 0? No. So I'm just going to put, look, this was a negative number. Is a negative number greater than 0? No. All right, all I care about is that it's negative. And a negative number is not going to be greater than 0. So we will have no solutions in this zone. Okay, now I'm going to erase this mess. All right, you better, when you're doing your work, I need to see all your work. So you're not allowed to erase. I'm just doing this so it fits on the screen. Okay, don't you do it. You can go off in the margins if you have to and do your work over there. All right, anyway, so now I need to check negative 1.1. All right, let's really try to do some shortcuts here. So I've got negative 1.1 plus 1 over 12 times negative 1.1, okay, plus 6. All right, I feel some shortcuts coming on. This is going to be 3 times negative 1.1 plus 4. All right, the numerator is easy enough. And look, let's just get it down to where all we care about is what's positive and negative. So look at the numerator. Is this going to be a positive or a negative? This is going to be a negative number, all right? Because negative 1.1 is bigger, that's going to turn out to be negative. Okay, what about this? This first set of parentheses, all right, this first factor is going to be negative. How do I know? Imagine that this was just a negative 1. Forget the 0.1 for a second. Negative 1 times 12 would be negative 12. Negative 12 plus 6 is going to be negative 6. It's going to be negative. So multiplying by negative 1.1 is just going to make this a slightly more negative number. All right, so I'm going to have a big negative number, bigger than this. So that's going to be negative. Okay, now this is a little bit closer. I'm not 100% sure. So I'm going to take my 4-function calculator and I'm going to do 3 times 1.1. So that turns out to be 3.3. So this would be negative 3.3. So negative 3.3 plus 4, that is going to be positive. All right, because the positive number is bigger. Okay. Now, a negative times a positive is a negative. So I'm going to have a negative. And then a negative divided by a negative is a positive. All right, so all I care about is the fact that this is positive. So is a positive number greater than 0? Yes, of course it is. A positive number is greater than 0. So that means this is a solution, and all of these will be solutions. All right, see how this works with the shortcuts? That's what you want to do. Let's do that again. All right, again, I'm erasing my work. You're not allowed to erase your work. Okay, let's look at negative 0.75. So I have negative 0.75 plus 1 over 12 times negative 0.75 plus 6. All right, this is tedious. And then I've got 3 times negative 0.75 plus 4. Okay, in the numerator, I'm going to have a positive number, all right, because the positive number is bigger. In the denominator, okay, what is 12 times 0.75? So I'm using my 4-function calculator. 12 times 0.75. Well, that's 9. So this is going to make negative 9. And obviously negative 9 and positive 6, that's going to give us a negative number. Okay. Now I'm doing 3 times 0.75. That's 2.25. So this is going to be negative 2.25. So that is a positive number. Once I add these together, the positive number is bigger. Okay. But a negative times a positive is a negative. And then we have a positive divided by a negative, so that is a negative. So is a negative number greater than 0? No. So we will have no solutions in here. Okay? Thankfully, the last one is easy. In fact, I don't think we even have to show the work over here because we can just use our common sense in this area. If we put 0 in for all the x's, 0, 0, 0. All right, that really wipes out this whole term and this whole term. So that just leaves 1 over 6 times 4. All of those are positive, so that's going to be a positive result. Is a positive number greater than 0? Yes. So that means everything in this interval will be a solution. So this is a nice graph of our solution set. That was very tedious to come up with. But hey, you got to do what you got to do. Now let's turn this into interval notation. So this first portion is going to be like this. I'm going to say negative 4 over 3 to negative 1. Negative 4 over 3 to negative 1. Notice I use parentheses and then a bracket because open circle and then close circle. Union, and then it will be negative 1/2 to infinity. All right, because it just goes forever in that direction. So this interval notation is actually the solution to this entire problem. All right, the rest is work that I need to see, including the part that I erased over here. I should see that work like scattered all around this problem. Okay, maybe even in the margin if you need the space. All right, hopefully the last 2 problems won't take quite that long. All right, I think that was the hardest one just because of the decimals. That was a pain. This does not look so bad. Okay, first we solve the related equation by turning this into an equal sign. The only way a fraction can equal 0 is if the numerator equals 0. So we really are going x plus 6 equals 0, which gives us x equals negative 6. So that is one critical value right there, x equals negative 6. We can get more critical values by paying attention to what x cannot equal. For example, the denominator can't equal 0. So x squared minus 36 cannot equal 0, which means that x squared cannot equal 36, which means that x cannot equal plus or minus 6. I just took the square root of both sides and I remembered my plus or minus. I also could have done the difference of two squares, x plus 6, x minus 6. Either way, you're going to get plus or minus 6. Okay, so those are two additional critical values. Okay, interesting. One of the values that x cannot equal to also is the value that we got for what x equals. So guess what? This gets overruled. X cannot equal negative 6. So that means there is no value of the function where the function is going to equal 0. It'll just never equal 0, right? It just absolutely cannot equal 6 or negative 6 because that would cause a 0 denominator. So that's no good. Okay, so fine. We have a critical value of positive 6 and negative 6. Okay, so let's go ahead and set up our number line. I think I'll do it down here. Okay, so we have negative 6 and we have positive 6. So let's do f at negative 7. Let's do f at 0. And let's do f at positive 7. X cannot equal either of these numbers. So these will definitely be open circles that we're talking about. All right, so how about 7? If I substitute in 7, then that's going to be 7 plus 6 over, and if I put 7 right there, that's going to be 49 minus 36. Okay, and the question is, will it be less than, all right, focus on this right here, will it be less than 0? That's the key. Okay, but this is going to be a positive, and this is going to also be a positive. So that's going to give us a positive. So will a positive number be less than 0? No, a positive number will never be less than 0. So this is going to be a big old no. So there will be no solutions here. Now, if I put in 0, if I put 0 here and here, that's just going to leave me positive 6 divided by negative 36. That is going to be a negative number. Is a negative number going to be less than 0? Yes, always. That means everything in here is going to be a solution. What about 7? Okay, well, you know what? I was supposed to do negative 7. I just did positive 7, didn't I, guys? So over here, when I did all my calculations, that was positive 7. So I got that positive. And is that less than 0? And the answer was no. Okay, but now I'm going to do the negative 7. So that was a mistake. I forgot the negative. So I should have said negative 7 plus 6. Okay, but if I put negative 7 squared, let me erase these marks here for a second. If I put negative 7 squared, that's still positive 49. Okay, that's still going to be positive 49 minus 36. So this is going to give me a negative divided by a positive. And a negative divided by a positive is a negative. Okay, so looking back, this was wrong because I put a positive when really it is a negative. So the question is a negative number going to be less than 0? And the answer is yes, always. So that means we will have solutions in this area. Okay, so this is what our graph will look like. And now let's put that in interval notation. So from this part right here, we have negative infinity to -6, then union, and then we have -6 to +6. So this interval notation is the solution to the entire problem. Okay, now we're down to the last one, problem number 23. All right, same steps that we did before. First, we solve the related equation. The only way this function can equal 0 is if the numerator equals 0. That's the only way. So that means x plus 6 has to equal 0. So x would equal -6. All right, so that is a critical value. But now we need to talk about what x cannot equal. Well, the denominator cannot equal 0. Let's go ahead and factor this. I'll just show this extra step. So the denominator cannot equal 0. So that means x squared plus 8x plus 15 cannot equal 0. We will solve this by factoring. All right, cannot equal 0. So x squared factors as x times x. 15 will probably factor as 3 times 5. It could be 15 times 1, but I see the 8 right here. So this is going to factor as x plus 3 times x plus 5. So by the zero product property, I'm going to set each of these equal to 0, and I wind up seeing that x cannot equal -3 because of this one, and x cannot equal -5 because of this one. So we now have 3 critical values. X equals this, and x cannot equal this or this. All right, 3 critical values. So here comes the number line. All right, so we have -6, and we have -5, and we have -3. So our test values can be -7. Okay, between -5 and -6, we're going to have to do a decimal. So let's just do -5.5, all right, which is annoying, but hey, we do what we have to do. Between -5 and -3, we will do -4, of course. And then over here, let's do 0. Always do 0 when you can. Let's decide whether these will be open circles or closed circles. Well, the ones where x cannot equal the number, those are automatically open circles. So x cannot equal -3, that's an open circle. X cannot equal -5, open circle. The other one depends on whether it's greater than or equal to. Because of the or equal to part, this one is going to be a closed circle. Now, let's test these values out. Okay, when I do this, I'm going to use the factored form. So for example, when I put in 7, I'm going to have 7 plus 6. I'm doing it again, so that's a -7. Okay, I'm going to do -7 plus 6. But I'm doing the factored form now, guys. So I'm going to have -7 plus 3 and -7 plus 5. Okay, so what happens? I'm going to get a negative number in the numerator. So I have a negative number. Whoops. I meant to just put a negative sign. So I'm going to have a negative, and then I have negative 7 plus 3. So that's going to be another negative. Then I have negative 7 plus 5. So that's going to be another negative. But a negative times a negative is a positive. But then a negative divided by a negative is a negative. So I'm going to get a negative. So the question is it greater than or equal to 0? So is a negative number greater than 0? And of course, the answer to that is no. So there will be no solutions in this interval. So now it's time to check negative 5.5. Again, you are not allowed to erase your work like I just did. I'm just doing this so it will fit on the video. You can do your work over here. You have infinite space. All right, but I'm trying to keep it all in frame. Okay, we're checking negative 5.5. So that's going to give me negative 5.5 plus 6. And that's going to give, and I'm doing the factored form here, guys. So that's going to be negative 5.5 plus 3 and negative 5.5 plus 5. And all I care about is what is negative and what is positive. So the numerator will be positive because the positive number is bigger. The first factor in the denominator will be negative because the negative number is bigger. And the second factor will also be negative because the negative number is bigger. But a negative times a negative is a positive. So I'm going to have this. But then a positive divided by a positive is a positive. So I'm getting a positive. Is that greater than 0? Yes, always. So that means we have solutions in here. Okay, time to check negative 4. All right, so that would be negative 4 plus 6 over negative 4 plus 3 times negative 4 plus 5. That is going to be a positive divided by, and I'll have a negative and a positive. A negative times a positive is a negative, and a positive divided by a negative is a negative. So I'm getting a negative. Is a negative greater than 0? No. No solutions in this interval. And last but not least is the 0. I don't need to do this. I can just put the 0 right here. So 0 here, 0 there, 0 there. Okay, that's going to wipe out everything except for this. Positive 6, positive 15. That is a positive number. So will a positive number be greater than 0? Yes. Yes, it is. So that means we will have solutions in this interval as well. Now it is time for the interval notation. So this first little portion right here goes from negative 6 to negative 5. And we'll go bracket and parentheses because closed circle, open circle. Union negative 3 to infinity. All right, with parentheses because it's an open circle. All right, so this interval notation is the solution to the whole problem.